March 1st, 1942, Ilion, New York. Remington Arms Company. A team of industrial engineers stared at a problem that was strangling America's war effort. Rifle barrels. Not enough of them. Never enough of them. Every day, completed rifle receivers sat idle on assembly lines because barrel production couldn't keep pace. The numbers were brutal. Remington's Pratt and Whitney rifling machines could cut exactly 160 grooves per barrel. 4 grooves, 40 strokes each to reach the required depth of .004 inches. Each stroke took time. Each barrel took hours. And America needed millions of rifles. Right now. The engineers had tried everything. Running the machines faster broke the cutters. Deeper cuts clogged the equipment. Adding more shifts meant training workers who didn't exist. The bottleneck was mathematical, physical, and seemingly insurmountable. Then someone asked a question that sounded insane. What if we just cut 2 grooves instead of 4? The room went silent, because rifling wasn't just tradition, it was physics. 4 grooves had been standard for decades. The British used it. The Germans used it. Springfield Armory had built 1 million rifles with 4-groove barrels. You didn't just change that. But one engineer wouldn't let it go. His name was never recorded in official histories, just listed as part of Remington's industrial engineering team. But he kept pushing. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Half the grooves means half the cutting time. If it works, we double our barrel production overnight. The Army needs rifles faster than we can make them. This could be the answer. The head of Remington's research division in Bridgeport, Connecticut, a man named Henschel, heard the proposal and saw the risks immediately. Those grooves aren't decorative. They spin the bullet. They create accuracy. 4 small lands, each about 0.2 inches wide, grip the projectile and impart rotation. You're proposing 2 huge lands, almost 0.3 inches each. That's massive surface area. The friction alone could slow the bullet dangerously. Chamber pressure could spike. The barrel could burst. Or worse, it could work initially and fail catastrophically in the field. Send American soldiers into combat with rifles that explode in their hands. But Henschel also saw the numbers. America was at war with Japan and Germany simultaneously. The M1903 Springfield, the only rifle Remington could produce quickly using government-owned machinery from Springfield and Rock Island arsenals, was desperately needed. The Monet Garand was better, but there weren't enough. Not nearly enough. The Marines landing at Guadalcanal, the Army preparing for North Africa, they needed rifles, thousands of them, tens of thousands. And rifle production was capped by one factor: how fast you could cut rifling grooves. Henschel made a decision that could have ended his career. Let's test it. But we test it right. Full battery, accuracy, velocity, pressure, barrel life, everything. If this fails in testing, fine. But if we don't try and American soldiers die because we couldn't arm them fast enough, that's on us. March 1st, 1942. The contract was signed. Remington's Ilion facility and their research division in Bridgeport would jointly investigate whether a 2-groove rifle barrel could match the performance of the standard 4-groove design. The team knew they were attempting something most firearms experts would call impossible. The physics problems were staggering. Rifling works by engraving the bullet as it travels down the barrel. The lands, the raised portions between the grooves, dig into the softer copper jacket of the projectile. That engraving creates the spin that stabilizes the bullet in flight. 4 narrow lands distribute that engraving force. 2 wide lands concentrate it. Would the friction be too high? Would the bullet slow down so much that it couldn't reach effective range? The engineers worried about pressure. When a primer ignites, chamber pressure builds instantly. The only thing preventing catastrophic failure is the bullet starting to move immediately. Any delay, any additional friction, and pressure spikes into dangerous territory. War emergency steel, the relaxed specifications they were already using to speed production, made this worse. The steel was softer, more prone to failure under pressure. A 4-groove barrel with standard steel was proven safe. A 2-groove barrel with war emergency steel was a complete unknown. Then there was accuracy. Military specifications required that a Springfield rifle put 5 shots within a specific group size at specific ranges: 100 yards, 200 yards, 600 yards. Would 2 grooves provide enough spin? Would the bullet drift? Would accuracy degrade? And barrel life. Soldiers couldn't be pulling triggers on rifles that wore out after a few hundred rounds. The army needed barrels that could withstand thousands of rounds of sustained fire without degrading. Would 2 wide grooves erode faster than 4 narrow ones? The British had tried 2-groove barrels in May 1941 for their Lee Enfield rifles. The trials showed promise. But British specifications weren't American specifications. British ammunition wasn't American ammunition. And Remington couldn't just copy British designs. They had to test everything from scratch. The manufacturing challenge was immediate. Remington's Pratt and Whitney rifling machines were designed for 4 grooves. Each machine had an automatic indexer that rotated the barrel 90 degrees between cuts, 4 positions, 4 grooves. To make 2-groove barrels, workers had to bypass the automatic indexer and rotate the barrel by hand. It was slow. It was imprecise. It defeated the entire purpose. If you wanted to manufacture 2-groove barrels at scale, you needed to redesign the indexing mechanism. That meant retooling. That meant downtime. That meant gambling that the concept would work before you'd proven it would. Henschel's team started small. 27 rifles, 27 hand-indexed 2-groove barrels. Each one a prototype, each one a potential disaster. The barrels went to the testing range, spring 1942. The indoor range at Remington's facility. A rifleman settled into position, prone, elbow rest, muzzle rest, standard government testing protocol. The first 2-groove rifle was loaded with standard M2 ball ammunition, the same rounds American soldiers would fire in combat. 4 shots, 100 yards. The target was brought back. Henschel measured the group, all 4 shots within the required circle. He moved to the next rifle. Same result. And the next. All 27 rifles passed the government inspection standard for accuracy at 100 yards. The team's initial panic began to ease. It works, at least at close range. But 100 yards proved nothing. Combat engagement ranges were longer, much longer. The team moved outdoors. 200 yards, 600 yards. They selected 2 of the best 2-groove rifles. For comparison, they pulled a standard 4-groove Springfield, serial number 1283325, from inventory. Henschel watched through his binoculars as the riflemen fired groups with each weapon. The 2-groove rifles were handheld. The standard protocol: no bench rest, no sandbags. Just a man, prone, with an elbow rest and muzzle rest, human accuracy, not mechanical accuracy, because that's what mattered in combat. The targets came back. At 200 yards, one 2-groove rifle averaged 3.19 inches, the other 3.66 inches. The 4-groove control rifle, 3.44 inches. The 2-groove barrels were performing identically to the Tanier, standard. At 600 yards, the pattern held. One 2-groove rifle produced 6.95-inch groups, the other 7.13 inches. The standard 4-groove, 7.03 inches. Statistical noise, no meaningful difference. Henschel's notes from the testing are preserved in Remington's archives. The 2-groove rifling equals the standard 4-groove rifling in performance. But he wasn't celebrating yet. Accuracy was one thing. Velocity was another. A slow bullet is a dead soldier. Combat effectiveness depends on the projectile reaching the target with enough energy to be lethal. The lands in a barrel create friction. More friction means slower bullets. 2 wide lands potentially meant massive friction. The team set up chronographs, instruments that measure bullet velocity by timing how long it takes to pass between 2 sensors. The results came back. Velocity loss was negligible. The two-groove barrels were producing muzzle velocities within 30 feet per second of the standard four-groove design. At 1800 feet per second, plus or minus 30, you couldn't tell the difference in combat. The bullet reached the target at effectively the same time, with effectively the same energy. But pressure was the killer. Literally. The engineers rigged copper crusher gauges, crude instruments by modern standards, but the best technology of 1942, a copper cylinder placed in the chamber. When the round fired, chamber pressure crushed the cylinder. The degree of crushing indicated pressure levels. Standard four-groove barrels with standard M2 ball ammunition produced known safe pressures. The two-groove barrels, with their massive lands creating additional friction, were unknown. The first test fired. The copper crusher was removed and measured. Pressure was higher, about 3,000 pounds per square inch higher. Not catastrophic, not dangerous with standard M2 ball, but higher. They tested armor-piercing ammunition. The pressure spiked. 4,000 pounds above standard, still technically safe, but pushing limits. Henschel made a note in his report. Since armor-piercing ammunition is seldom used in the Springfield rifle, this latter result is not particularly significant. It was a calculated risk. A gamble that American soldiers would mostly fireball ammunition, not armor-piercing rounds. A gamble that would prove correct. The endurance test was brutal. Take a rifle, fire 500 rounds through it, not carefully aimed shots from a bench. Combat conditions, 10 rounds in 1 minute. Fire until the barrel is hot. Shoot for accuracy while the metal is still radiating heat. Repeat in cycles of 50 rounds until you've put 500 rounds down range. Then check the barrel for wear. The rifleman fired. The barrels heated until you couldn't touch them. The wood handguards smoked. They kept firing. After 500 rounds, the barrels were pulled and examined. Bore erosion was measured using sulfur casts, pouring molten sulfur into the barrel, letting it harden, and extracting a perfect negative of the rifling. The casts were measured with precision instruments. The two-groove barrels showed no significant wear compared to four-groove standards. The accuracy hadn't degraded. The rifling hadn't eroded catastrophically. After 500 rounds, the two-groove barrels were still functioning within specifications. One rifle was pushed further. 16,000 rounds. That's the equivalent of years of combat use, compressed into days of testing. The barrel was fouled. Heat checking was visible at the breech where hot gases eroded the steel, but there was no measurable wear to the rifling itself. The two wide grooves weren't eroding faster than four narrow ones. Henschel compiled his data. On the basis of tests made to date, the two-groove rifling equals the standard four-groove rifling in performance. It was a qualified statement. Not better. Equal. But equal was enough, because equal meant it worked. And if it worked, they could double production. The question now was whether anyone would believe them. Summer 1942. Aberdeen Proving Ground, Maryland. The U.S. Army's testing facility, where every weapon, every piece of equipment, every innovation had to prove itself under the harshest conditions the military could devise. Remington's two-groove barrels arrived for independent evaluation. The Ordnance Department wasn't taking Remington's word for it. They ran their own tests, their own riflemen, their own ammunition, their own standards. The results mirrored Remington's findings. The two-groove barrels performed identically to four-groove standards. Accuracy within specifications, velocity within acceptable range, pressure elevated but safe, barrel life adequate. But the Ordnance Committee didn't meet until October 22nd, 1942, 7 months after Remington started testing. 7 months of war. 7 months of soldiers needing rifles that weren't being produced fast enough. The committee reviewed Aberdeen's data. They reviewed Remington's reports. They reviewed the British experience with two-groove Lee Enfields. No one could argue with the performance. The two-groove barrels worked. The recommendation went up the chain. Approved two-groove rifling for the following rifles. U.S. Rifle, caliber .30, Monet Garand. U.S. Rifle, caliber .30, M. 1903 Ione. U.S. Rifle, caliber .30, M. 1903 A3. U.S. Rifle, caliber .30, M. 1917. Every major American rifle. Approved for two-groove production. But here's what the official reports don't tell you. The resistance, the institutional inertia, the old guard officers who believed that rifling had been perfected decades ago and any change was degradation. There were ordnance officers who argued that even if the barrels performed identically in testing, they would fail in combat. That the psychological impact on soldiers would be devastating when they received rifles with inferior barrels. That American soldiers deserved better than wartime shortcuts. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. One memo, recovered from archives after the war, argued that issuing two-groove rifles would damage morale more than the marginal increase in production was worth. That soldiers would lose confidence in their weapons. That the enemy would seize on it as proof that American production was faltering. The counter-argument was mathematical. The Atlantic Wall was being built. Operation Torch, the invasion of North Africa, was being planned. The 1st Marine Division was fighting in the Pacific with bolt-action Springfields because there weren't enough Garands. The United States was trying to arm millions of men. Millions. And rifle barrel production was the limiting factor. You could have the best rifle design in the world, but if you couldn't produce enough barrels, soldiers went into combat underarmed. The two-groove design would cut rifling time in half, 40 strokes per groove instead of 160. That meant a Pratt & Whitney machine that previously produced X barrels per day could now produce 2X barrels per day. Same machine, same operator, double the output. The math was undeniable. If you could double barrel production, you could arm twice as many soldiers. And every soldier armed with a rifle was a soldier who wasn't fighting with a pistol, or worse, nothing at all. The approval came down. Late 1942. Production was authorized. All M1903A3 rifles would now be manufactured with two-groove barrels as standard. Remington could finally retool their indexing mechanisms. The change wasn't advertised. There were no press releases about revolutionary new barrels. In fact, the Army was careful to downplay it. Every M1903A3 rifle with two-groove barrels shipped with a printed notice, a small slip of paper tucked into the packaging. The reduction in rifling grooves does not affect accuracy. It was defensive, preemptive. The Army knew soldiers would notice, knew they would ask questions, knew they might doubt their weapons. So they stated it explicitly. This isn't inferior, this is different. It works. But the notice revealed something deeper. The anxiety about perception. The worry that American soldiers, trained to believe in the superiority of American equipment, would lose faith if they received anything that looked like a compromise. Winter 1942-43. Remington's production lines hummed. The retooled indexing mechanisms worked exactly as designed. Barrels that previously took hours now took half the time. The bottleneck broke. Rifle production accelerated. By late 1942, Smith Corona typewriter companies, plant in Syracuse, New York, began producing M1903A3 rifles. They used two-groove barrels from the start, a typewriter company making rifles. That alone tells you how desperate American production was. But Smith Corona had precision machinery, skilled workers, and factory space. They could be converted to rifle production, and with two-groove barrels, they could be productive immediately, without the learning curve of four-groove rifling. The numbers accumulated. Through 1943 and into 1944, Remington and Smith Corona produced approximately 1,415,593 M1903A3 and M1903A4 rifles. Roughly 750,000 of those had two-groove barrels. 750,000 rifles that wouldn't have existed, or would have been produced months later, without the two-groove innovation. That's rifles for 750,000 soldiers, and every soldier armed is a soldier who can fight. The Pacific Theater absorbed thousands. Marines at Tarawa, Guadalcanal, Saipan. Army units in New Guinea, the Philippines. Two-groove Springfields went into combat across the Pacific. European Theater, the M1903A4 sniper variant, built on the A3 action, often with two-groove barrels, went to marksmen in every division. Italy, France, Germany, snipers peering through weaver scopes, squeezing triggers on rifles that technically shouldn't exist. Training camps stateside consumed even more. Every recruit needed a rifle for basic training, every officer candidate, every specialist school. The two-groove barrels meant training could continue at pace while frontline units got priority for Garands. And here's what matters. They worked. Combat reports from the Pacific. No mention of barrel failures, no reports of accuracy problems. Marines at Tarawa carried two-groove Springfields into the most brutal close quarters, combat of the war. They worked. Sniper reports from Europe. M1903. A4 rifles with two-groove barrels, producing accurate fire at 600 yards and beyond. They worked. Post-war examination of captured rifles by Japanese and German forces. Technical intelligence reports, recovered after the war, show both enemies analyzed American rifles carefully. They noted the two-groove barrels. They tested them. The Germans conducted accuracy trials with captured two-groove Springfields. Their conclusion, documented in Waffenamt reports, no measurable difference in combat effectiveness compared to four-groove examples. The Japanese reached similar conclusions. The Americans had found a way to increase production without sacrificing performance. But here's what the enemy didn't know: how close it came to not happening, how many ordnance officers opposed it, how much institutional resistance had to be overcome. The two-groove barrel wasn't inevitable. It was the result of engineers asking a question that seemed crazy. Industrial engineers at Remington, names mostly lost to history, looking at a bottleneck and asking, what if? And then actually testing it, actually proving it, actually pushing it through a military bureaucracy that didn't want to change. Henschel's team, working through spring and summer 1942, probably saved months of production time. If they'd waited until 1943 to start testing, if they'd been more cautious, if they'd let institutional resistance stop them, American soldiers would have gone into combat underarmed, maybe not many, maybe just a few thousand. But in war, a few thousand rifles can mean the difference between a defensive line holding or breaking, between a platoon surviving or being overrun. The production impact was global. Remington's two-groove design was shared with Smith Corona. British two-groove Lee Enfield production, which had started slightly earlier in 1941, was validated by American success. Canadian Long Branch Arsenal, producing Lee Enfields, adopted two-groove rifling. Savage Arms, producing Enfields for the British under US property markings, used two-groove barrels. The innovation rippled across the Allied arms industry. Not because it made rifles better, because it made rifles faster. Post-war, the two-groove design was largely abandoned. Once the urgency of wartime production ended, manufacturers reverted to four-groove standards. Why? Not because two-groove barrels were inferior, but because they were emergency measures, war emergency steel, war emergency production methods, war emergency specifications. When the war ended, emergency was over. Standards could be restored. But during the war, when it mattered, two-groove barrels armed 750,000 American soldiers who might have gone into combat with inadequate weapons or delayed deployments. That's not nothing. The engineers who made it happen received no medals. Henschel's name appears in technical reports, not history books. The industrial engineers at Ilion, whose names were never recorded in official documents, they're completely forgotten. The workers who retooled the indexing mechanisms. The machinists who hand-rotated the first 27 prototype barrels. The riflemen who fired 500-round endurance tests, all anonymous. But their work changed the war. not through a brilliant tactical innovation, not through a wonder weapon, through a production optimization, through asking whether a century of tradition was actually necessary or just traditional, through testing instead of assuming, through data instead of doctrine. The two-groove barrel is a footnote in most histories of World War II, a technical curiosity, a minor production detail, but to the soldier carrying a rifle produced in 1943, that detail was everything. The Springfield in his hands existed because someone asked a crazy question and then proved it wasn't crazy after all. That's innovation, not the flashy kind, the practical kind, the kind that doesn't make headlines but makes differences. The engineers at Remington didn't set out to revolutionize warfare. They set out to solve a production bottleneck. They succeeded. 750,000 rifles that wouldn't have existed otherwise. 750,000 soldiers armed when they might have waited months for weapons. In the calculus of total war, that matters. Every rifle matters. Every soldier armed matters. The two-groove barrel wasn't glamorous. It was effective. And in 1942, when America was fighting for survival across two oceans, effective was everything. The technical specifications survive in archives. Bore diameter, 0.300 inches. Groove depth, 0.004 inches. Number of grooves, 2 instead of 4. Rifling twist, 1 turn in 10 inches. Chamber pressure, elevated but safe. Accuracy, equal to 4-groove standards. Barrel life, adequate for military service. Those numbers represent hundreds of hours of testing, thousands of rounds fired, dozens of engineers working through the problem, and ultimately, a decision by military officials to trust the data over tradition. That decision armed an army. The two-groove Springfield rifle served through the end of World War II. Korea saw some service, mostly rifles pulled from war reserves. By Vietnam, they were obsolete, replaced by M14s and M16s. But in the critical years, 1942 through 45, they were everywhere. Training camps, combat zones, sniper positions, guard posts, front lines and rear echelons. A rifle that existed because someone asked, "What if?" and then had the courage to test whether the answer was yes. The human cost of that innovation is harder to calculate. How many soldiers lived because their rifle was produced 3 months earlier than it would have been with 4-groove barrels? How many missions succeeded because units were fully armed instead of under-equipped? The counterfactual is impossible to prove, but the mathematics suggest an answer. American rifle production in 1942 was constrained by barrel manufacturing. If 2-groove barrels doubled the production rate, and they did, then 750,000 rifles were produced that would have otherwise been delayed by months. Those delays would have cascaded, training schedules adjusted, deployment timelines pushed back, units sent into combat under strength. The 1st Marine Division at Guadalcanal in August 1942 fought with M1903 Springfields, not Monet Garands, because Garand production couldn't meet demand. If Springfield production had also been constrained, those Marines might have landed with even fewer rifles. Might have. The alternate timeline doesn't exist. But the possibility haunted the engineers who worked on the project. Henschel's personal papers, donated to archives after his death, include a letter to his wife from March 1942. "We are testing a barrel design that might sound like a shortcut, but could mean the difference between soldiers having rifles or not having them." I think about that every day. Every test we run, every measurement we take, there are young men whose lives might depend on whether we get this right. He got it right. His team got it right. The industrial engineers got it right. The workers who retooled the machines got it right. The system, despite institutional resistance, eventually got it right. The two-groove barrel entered production. The rifles reached soldiers, and when those soldiers squeezed triggers in combat, the rifles performed exactly as designed. But the story doesn't end with production numbers and combat reports, because the two-groove barrel represented something larger than a manufacturing optimization. It represented a shift in how America approached warfare. World War I had been fought with craftsmanship, hand-fitted parts, precision machining, the idea that quality came from skilled labor and time-intensive processes. The M1903 Springfield originally embodied that philosophy. Every rifle individually crafted to exacting standards, beautiful pieces of engineering, but slow to produce. World War II demanded a different approach. Mass production, interchangeable parts, assembly lines. The philosophy wasn't make it perfect, but make it good enough, and make 1 million of them. The two-groove barrel was the ultimate expression of that philosophy. Not perfect, not traditional, not what experts said rifling should be, but good enough for combat and fast enough to matter. The resistance to that philosophy was real. Officers trained in the old methods saw shortcuts everywhere and worried that quality was being sacrificed for speed. They weren't entirely wrong. War emergency steel was lower quality than peacetime standards. Stamped parts replaced, machined components. Finishes were rougher, tolerances were looser. But the alternative was losing the war. Because Germany and Japan weren't waiting for America to craft perfect rifles. They were bombing Pearl Harbor, invading the Philippines, occupying Europe. The enemy didn't care about American manufacturing philosophy. They cared about how many rifles you could field. The two-groove barrel was America's answer. We can produce faster than you can destroy. We can arm soldiers faster than you can kill them. We can outmaneuver you through sheer industrial capacity. It wasn't the weapons that won World War II. It was the factories, the assembly lines, the workers, the engineers who found ways to make production faster without making quality insufficient. Henschel's team at Remington was one small part of that. But their part mattered. 750,000 rifles mattered. The story of the two-groove barrel reveals something about innovation that's easy to miss. The best. Innovations often aren't revolutionary. They're evolutionary. They're someone looking at an existing process and asking, do we really need to do it this way? Four-groove rifling worked. It had worked for decades. It would have continued working. But it was slow. And in 1942, slow meant deadly. The innovation wasn't in the barrel design itself. Two-groove rifling wasn't new technology. The British had used it on percussion rifles in the mid-1800s. The innovation was in recognizing that wartime demands had changed the equation, that what was optimal in peacetime might not be optimal in war. That tradition needed to be questioned, and then actually questioning it, actually testing it, actually pushing through institutional resistance to prove that different could be equal. That's harder than it sounds. Institutions have inertia. The military, especially, values tradition and proven methods. Changing specifications requires approvals at multiple levels. Risk, assessment, testing protocols, bureaucratic review. The easy path is to keep doing what you've been doing. The hard path is to prove that change is necessary and beneficial. Remington's engineers took the hard path. They didn't wait for the military to request two-groove barrels. They proactively investigated whether it would work. They spent their own resources on testing. They built the evidence case before anyone asked for it. That proactive innovation was crucial. If they'd waited for military specifications to change before starting research, the timeline would have extended by months. By the time two-groove barrels entered production, battles would have already been fought with insufficient rifles. In any crisis, whether military or civilian, the organizations that survive are the ones that can adapt quickly, that can question their own methods, that can distinguish between we do it this way because it's best and we do it this way because we've always done it this way. Remington's engineers made that distinction. They recognized that four-groove rifling was tradition masquerading as necessity. When tested against two-groove alternatives, it wasn't superior, it was just traditional. That recognition saved months of production time, and in war, months matter. The combat performance of two-groove rifles provides the ultimate validation. Soldiers are practical. If a rifle doesn't work, They complain, loudly. They write letters home. They file reports. They request replacements. The two-groove Springfields generated no significant complaints, no unusual failure rates, no accuracy problems. Soldiers in the Pacific and Europe used them exactly as they would have used four-groove versions, because functionally they were identical. German intelligence reports from captured two-groove rifles are particularly telling. The Germans were desperate to understand American production methods. How was the United States outproducing the Third Reich so completely? Technical analysis of captured weapons was a priority. When German ordnance officers examined two-groove Springfields, they noted the innovation. They tested accuracy. They measured velocities. They compared performance to four-groove examples. Their conclusion: no meaningful difference. But they also noted something else: the production efficiency. One report, recovered from German archives after the war, estimated that two-groove rifling could increase barrel production by 40 to 50%. The German conclusion: the Americans have optimized for mass production at the expense of traditional craftsmanship. The result is adequate weapons produced in overwhelming numbers. That wasn't criticism. It was grudging respect, because the Germans understood what it meant. They were fighting an enemy that could replace losses faster than they could inflict them, an enemy that could arm soldiers faster than they could kill them. The arithmetic of attrition favored whoever could produce more. Two-groove barrels contributed to that advantage, not in any dramatic way, not with headlines or propaganda, just by quietly increasing the number of rifles rolling off production lines every day. 750,000 rifles over approximately 2 years. That's roughly 1,000 rifles per day, every day, that existed because of two-groove production. 1,000 soldiers armed, 1,000 rifles in combat, 1,000 potential differences. The engineers who made that happen worked in obscurity. Factory floors in Ilion and Syracuse, testing ranges at Aberdeen, design offices in Bridgeport. No cameras, no reporters, no public recognition. Just engineers doing what engineers do, identifying problems, testing solutions, implementing changes. That's how wars are won, not through singular acts of heroism, though those matter, through accumulated improvements, through thousands of small optimizations that collectively create overwhelming advantage. The two-groove barrel was one optimization among thousands. Stamped metal parts, simplified assembly procedures, war emergency steel, each one a compromise. Each one a recognition that perfect was the enemy of good enough. Together, they transformed American production capacity. The M1903A3 Springfield, the rifle that bore most of the two-groove barrels, was itself a product of that philosophy. It was a simplified version of the M1903, cheaper sights, stamped components, rougher finish, everything optimized for production speed. Traditional gunsmiths hated it. They saw degradation of craftsmanship, loss of quality, the industrialization of a profession that had been art. They weren't wrong about the craftsmanship. The M1903A3 was objectively less refined than earlier Springfields, but they were wrong about quality where it mattered. In combat, the A3 worked. It fired accurately. It survived harsh conditions. It brought soldiers home. That's quality. The rest is aesthetics. The two-groove barrel fit perfectly into that philosophy. It was less traditional, less refined, less what rifling was supposed to be. But it worked, and working was enough. Post-war, when collectors and historians began analyzing military rifles, the two-groove barrels generated controversy. Some collectors considered them inferior. War production shortcuts, emergency measures, not real Springfields. Market prices reflected that bias. Two-groove rifles often sold for less than four-groove examples. Collectors wanted authentic rifles, pre-war standards, traditional craftsmanship. They were missing the point. The two-groove rifles were more authentic to World War II than pre-war examples. They represented what the war actually was, not glorious charges and heroic stands, but industrial production, Mass manufacturing, pragmatic optimization, doing what worked instead of what looked right. Rifles told the real story of how America won, through factories, not fortresses, through production lines, not front lines, through engineers who questioned tradition and workers who implemented change. The lesson matters today. In any crisis, the winners are the organizations that can adapt, that can question their own methods, that can implement change quickly. Remington's engineers in March 1942 faced a bottleneck that threatened to limit American combat effectiveness. They could have accepted it, blamed it on circumstances beyond their control, waited for someone else to solve it. Instead, they asked a question, tested an answer, proved it worked, implemented it across the industry. 6 months from concept to production. In modern military procurement, that timeline seems impossible. But it happened because the need was urgent and the resistance was overcome. The engineers had data, the military had necessity. Together, they changed specifications that had been standard for decades. That's the power of crisis. It forces organizations to re-evaluate what's actually necessary versus what's just traditional. It creates permission to experiment, to test assumptions, to implement changes that would never happen in peacetime. The two-groove barrel benefited from that permission, but it still required someone to take advantage of it, to actually propose the change, actually test it, actually push it through approval channels. Henschel and his team did that. Their names deserve to be remembered alongside more famous military innovations, not because two-groove barrels were revolutionary, but because they were exactly what was needed when it was needed. That's harder than revolutionary. Revolutionary innovations often fail because they're too ambitious, too expensive, too complicated, too different from existing systems to integrate easily. Incremental innovations like the two-groove barrel succeed because they're compatible with existing infrastructure. They don't require complete retooling, don't demand new training, don't disrupt supply chains. They just make the existing system more efficient. That's unglamorous. That's why it doesn't make history books. But it's effective. The American military in World War II understood that better than any previous force. Incremental improvements across every system. Better logistics, faster production, more efficient training, each improvement small, collectively overwhelming. Not a wonder weapon, not a technological breakthrough, just a smart optimization that made production faster, 750,000 rifles faster. And 750,000 rifles was enough to matter. The final word count on human impact is impossible. How many soldiers lived because their unit was fully equipped instead of under strength? How many battles were won because reserves had adequate rifles? How many training programs continued on schedule because rifles were available? The counterfactuals are endless. But the logic is simple. In war, more is better than less. More rifles means more armed soldiers. More armed soldiers means more combat power. More combat power means more victories. The two-groove barrel increased the more. Not by revolutionizing weapons, by removing a bottleneck, by making production faster. The engineers who did that weren't thinking about history. They were thinking about production schedules, about backlogs, about soldiers who needed rifles. That practical focus produced lasting impact. 750,000 lasting impacts, each one a rifle that might not have existed without their innovation. The two-groove Springfield rifle was phased out after World War II. By Korea, most had been replaced or upgraded. By Vietnam, they were museum pieces. But for a critical period, 1942 through 45, they were everywhere. Combat zones, training camps, guard posts, supply depots. Everywhere rifles were needed, two-groove Springfields were there. Because someone asked a question that sounded crazy, because someone tested it instead of assuming, because someone pushed it through institutional resistance. Because someone recognized that tradition isn't sacred when lives are at stake. That's the real story of the two-groove barrel, not the technical specifications, not the production numbers, the willingness to question assumptions, the courage to test alternatives, the persistence to implement change. Those qualities won World War II, not weapons, not tactics, not strategy. The ability to adapt, to optimize, to do whatever worked instead of whatever was traditional. Remington's engineers in Ilion had that ability. They used it. 750,000 soldiers benefited. That's worth remembering. Not because the two-groove barrel was special, because the people who created it recognized that special wasn't necessary. Adequate was enough. Fast was crucial, and questioning tradition was patriotic. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.